So we're here from iSpecimen from the Medical University of South Carolina and Health Sciences of South Carolina to talk about FHIR apps for bioresearch. We're going to do some introductions, talk about the issues around bioresearch, some of which have been touched upon, what platforms we're using, and then how we tie it together using FHIR. I'm Doug Williams. I'm the CTO of iSpecimen here from Boston. I'm here with Dr. Chris Metz from MUSC and Dr. Les Leonard from HSSC and MUSC.
All right, the main frameworks we're going to be talking about today are Apple Research Kit and REDCap, which has already been talked about a little bit by Amy. And the applications we're going to be covering is iSpecimen. Doug's going to be talking about iSpecimen, which is a bioresearcher marketplace. I'm going to talk about Status Post, which is an application I have developed to integrate REDCap with Apple's Research Kit. And then finally, Les and I are going to talk about how we tie all this together using HSSC's FHIR web service. And also we'll talk a little bit about how we're working with Epic. So we have three main goals with the integrations that we're doing here. Number one is we want to provide a very efficient mechanism to educate potential participants in studies about studies, to give them a way to provide a mechanism to get informed consent to collect clinical data as well as clinical specimens. And then we want to create a statewide data exchange of these prior consented patients. And then the third main focus is to give researchers the tools necessary to be able to find these patients, know their phenotype, and find their specimens as well. So a little bit of background on the applications and frameworks that we're tying together. Apple Research Kit is an open source framework released about 2 years ago. And it is a software development kit that makes it easier for researchers and developers to create mobile applications for medical clinical research. They have a number of provided modules, surveys, informed consent, something called active task, which is a little difficult to explain in a short amount of time, but I like to think of it as a way of providing context to the data you're collecting. But one, it's not a shortcoming, it was by design. Apple did not create a back end to store the data that's collected through this tool. And so it's up to developers to come up with their own mechanism for that. And I chose REDCap because, as we've already learned, that is a tool that's very popular among researchers around the world. They already know how to use these tools. The added benefit of using REDCap as the back end for storage is that it also allows me to let the investigator create the design of the study itself inside of REDCap. And so with the Status Post application that I've created that integrates these two platforms, it's much easier, much faster, much cheaper to create these kind of applications.
Okay, thanks, Chris. Now we're going to talk about the three main platforms. The first platform is iSpecimen. We're building a marketplace for bioresearchers so that they can search for consented patients and specimens based on de-identified data that we're getting from a nationwide network of hospitals and labs.
I've already mentioned this a little bit, but I've created an iOS platform that consists of both of an iOS application as well as a cloud component that integrates Research Kit with REDCap so that you can rapidly develop and deploy Research Kit-based apps.
Health Sciences South Carolina is one of the things they're connecting to. Health Sciences South Carolina is a learning health system collaborative involving the 4 largest health systems in the state of South Carolina. There are about 2.5 million patients on whom we have longitudinal records. We have about 4 million identified individuals, and we have an MPI that links those individuals. over the past 6 months, we've developed a FHIR interface to that electronic MPI, and that what we've been doing here is collaborating to demonstrate the one of the first uses of that interface to further our mission on research, really. So,
great. So those are the main components. This is the problem we're trying to solve. Is it's been touched on. There's a really big growing demand to find consented patients and biospecimens, particularly at the early stages of the preclinical trial stages when people are doing biomarker discovery. And we're working together. Today that's done without data and without interoperability and fairly inefficiently, and we're working to try to use FHIR and use interoperability to speed up the whole process. And so that's what we're talking about here. So on the left is are the bioresearchers. We're going to show you how we can join our systems together to bring in, allow the bioresearchers to tie in to the hospitals and labs.
So I get to explain the lanes that are going on here. So EPIC is the EHR that's our target. We have REDCap as our database. Status Post is the data capture tool for patients that's going to get their consent. Our Health South Carolina database, which has the patient identifiers in it and helps us map that to a specified individual and find the EHR record. iSpecimen, which the investigator has ordered the specimen in. And then our pathology lab over here, where we'll actually grab the tube and then get it on the way to the researcher as specified. And so what we're going to do is walk across all these lanes in the next 7 slides.
Okay, you tell the story about the county fair.
Oh, well, yeah, I'm sorry. You know, we're a very interoperable group here. So that, imagine that Mary has gone to the Carolina Coastal Fair and wants to sign up to contribute her surplus blood or an extra tube for a specific research study. How could we make that happen at that particular site using FHIR? So,
all right, starting in the blue column here with Status Post, again, which is the integration of Research Kit and REDCap, the user downloads this app from the Apple Store. As soon as they download the app and open it, it downloads the study design that the investigator has put into REDCap. At that point, the user is asked to enter some demographic information, and then with my app talks to the FHIR interface at HSSC to validate that that is actually the person who they say they are. If they pass that validation step, the FHIR interface returns to me the MRNs for that patient at all of the participating institutions in South Carolina that are a part of HSSC. We then move on to the screening questions, and we have a little example of how that's designed in REDCap in the lower left. These are some example screens of what that validation process would look like that's happening between my Status Post app and the FHIR HSSC interface to the eMPI. Once a validation has been completed, if it is completed, we move on to the screening questions. And if the user passes the screening questions, then we start the informed consent process, which is based on the informed consent modules that come with Research Kit. If the user provides consent for a capture of data and specimens, then my app at that time creates a research ID. And then we do several things with that research ID. First, we pass that and only that to iSpecimen, so that this whole process can happen in an anonymous, de-identified way. After that, I take the research kit, the research ID with the MRNs that were provided by the eMPI interface, and I put those into REDCap. And then REDCap is configured with a technology called dynamic data pools, which can pull clinical data out of the HSC clinical data warehouse in a de-identified way and put that information in REDCap as well. And then finally, the research ID is also passed into EPIC. Oh, and I'm sorry, and here are a few example screens. Again, this is Research Kit module informed consent. the investigator has access to configure this to their liking.
This is the what you just described.
Yeah.
Okay, so after we have gotten the electronic data from HSSC into REDCap, we're going to transmit that anonymized data linked to the research ID to iSpecimen so that they can do the data mining to find the patients that there are. We've also passed that research ID, that this is a patient of interest, back to Epic. The next time this patient comes in to be seen for a routine blood draw, we've noted that the research ID is present and that a lab test to draw an extra tube is automatically created within Epic. There are also some other notifications that are done for us to be able to identify that this is actually an appropriate patient of interest. When that happens, a message is transmitted to the lab along with the message to capture the extra tube at the phlebotomy department. Last, we notify the clinical laboratory to pass that data along with the specimen to iSpecimen.
So this is illustrating the final part of the process. So we've got research IDs, which is de-identified data, tied to inside the firewall is the actual patient data. Then we can actually direct those specimens to either us to consolidate or directly to the bioresearcher. So with all the work that has been done by MUSC and HSSC, we're able to take advantage of that to then ultimately fill the bioresearcher's requirements all electronically. And so that illustrates what we're trying to do, and it really builds on a lot of work that had been done. The Epic implementations, the HSSC, these are many year efforts. But now we're at the point where with interoperation, we can really achieve things that could not otherwise be done in using FHIR in particular. So here's our contact information that'll be published when the presentations are published, and will be available afterwards for if any questions. So thank you all very much.